Thank you for buying our standard hydraulic trainer, part of our hydraulic and pneumatic trainer series. We fitted this trainer with everything you'll need to teach your students hydraulics. You can use your own lessons or follow our labs in the provided manuals, which includes a digital version. What was included? Your package includes a standard hydraulic trainer, single or double-sided, 18 hoses per side, 1 pressure release hose per trainer, a box of accessories including pressure gauges, flow meters, shuttle valve, check valves, ball valves, tees, needle valves, flow controls, a female-to-female coupling, extra interchangeable valve, manual with labs and trainer-specific information. The initial setup. When you first receive your trainer, you'll notice some of the valves on the right have no labels. You'll find these labels in the packaging near the manual. These magnetic labels can be placed and removed from the valves. Students can practice their understanding of hydraulic drawings if you have them figure out where they belong. At the bottom of the trainer, you'll notice there are ball valves on the suction line coming off the reservoir before the pump. These have been closed for shipment in case of damage that could cause a massive oil drain. You'll need to open these ball valves. If you purchase a single-sided trainer, there will only be one, as the single-sided version only has 1 pump. To get the trainer running, plug the electrical box into a 120 outlet. Grab 2 hoses, connect the first hose from the pressure porting block located at the bottom right of the trainer into the in of the flow meter. Connect the second hose from the out of the flow meter to the tank porting block located on the bottom left of the trainer. Make sure the needle valve above the relief valve is tightly closed. This ensures the oil does not bypass the system you have hooked up. The pressure release is usually used to drain system pressure after the lab has been completed before students remove the hoses. Once all hoses are firmly connected, you can now initiate the pump via the electrical box. You should now see the amount of flow the pump is giving, and the pressure gauge connected to the pressure port block will tell you how much pressure it's taking to do the job. Once you're done, turn the pump off. Drain any pressure to the tank by opening the pressure release needle valve. It is a good practice to get in the habit of draining this before removing any hoses. Now you can easily remove the hoses. Let's familiarize you with the trainer. We'll look at the most common trainer we make. The double-sided hydraulic trainer will include information on any variations the single trainer version has on the screen. To begin, we'll look at the bottom of the trainer. The lower half of the trainer houses 5 main components: the reservoir, which holds all the oil in the system, the pump, which pumps oil from the reservoir, the accumulator safety valve, and the oil filter. We can simulate aeration and cavitation with our system. Slightly closing the ball valve will cause cavitation. Notice changes in the oil through the sight gauge. Slightly open the needle valve. This will introduce air into the system, causing aeration. The accumulator can be activated by opening the ball valve going to it, which then allows the oil to charge it, and it to affect the system via the pressure porting block. The accumulator will not work if the accumulator drain ball valve is open. It must be closed, otherwise it will simply drain directly to the reservoir. The B side can be used with the accumulator as well by connecting a hose from the A side's pressure porting block to the B side's pressure porting block. The oil filter will likely never need to be replaced, but it will maintain a clean system, and you can monitor the health of the filter via the filter gauge. The side of the trainer with the flow sight gauge is the A side, or the main side. This side has a 3 gallon per minute variable volume pump. The vane pump is set at 500 psi, while the relief valve above is set at 600 psi. The student should only adjust the vane pump on the A side. The relief valve above is set to protect against student error. The instructor can demonstrate how to set the pressure of the relief valve. To do this, the instructor should increase the pressure of the relief valve, then turn the system on and close the pressure relief needle valve. The instructor should then increase the vane pump pressure to 600 psi. Then bring the relief valve down until it starts to drain over. Now the instructor can decrease the vane pump pressure until the gauge reads 500 psi. The B side is different. The B side, or back side of the trainer, has a 2 gallon per minute gear pump, with an attached relief valve. The lower relief is set at 600 psi and the relief at the top is set at 500 psi. Because this is a gear pump, oil will always be going over the relief valve that is set the lowest. Students can adjust the top relief valve, and if they go above 600 psi, the lower relief will kick in and start draining pressure at the source. The instructor can demonstrate how to set these two relief valves as well. To do this, increase the pressure of the bottom relief valve, then turn the pump on and increase the top relief valve to 600 psi. Now decrease the pressure of the lower relief valve until it starts draining. Then decrease the pressure of the top relief valve to 500 psi. The relief at the gear pump is adjusted by us, and it is not necessary to adjust. Single-sided trainers do not have the vane pump. They have the 2 gallon per minute fixed gear pump. The settings are the same. Now let's look at the top of the trainer. In most cases, both sides are identical. The only variations are due to the pump that operates each respective side. The flow meter will usually be 5 gallons per minute for the vane side, while the B side will typically have a 2 gallon per minute flow meter. Hand valves and solenoids will also differ. A side uses a vane pump, which is why valves on this side can have closed center valves and float center valves, because the vane pump does not waste energy when there is nowhere for the oil to go. The B side uses a gear pump, which requires open center valves or tandem center valves. Otherwise, oil will be running over the relief valve, getting the oil hot. The electric box has the pump power switch that powers the pump, the two-way switch that activates the two-way valve, the 3-position switch that controls the solenoid valve, the flow meter light which lights up when the set flow is reached on the flow meter, the proportional joystick that controls the proportional valve. This joystick has adjustments that alter the way the proportional valve will work with it. The 24-volt switch must be set to on for the proportional valve to work, and sometimes the solenoid and two-way require it as well. The pressure porting block has 4 connections that can be made, although T's can be introduced to expand on this. The pressure port block is connected to a pressure gauge, relief valve, and a pressure release needle valve. Pressure can be released through this needle valve. This should be done each time before removing hoses. This is a good practice to maintain. The valve on the right side includes a pressure temperature compensated flow control, a pressure reducing valve, a counterbalance valve, a pilot operated check valve, a two-way valve, a sequence valve, and a flow divider. Next to that, you have a flow meter and a hydraulic motor. This motor has an adjustable torque that can be tightened to increase tension. The middle of the trainer includes a cylinder that actuates a cam valve, a spring-loaded cylinder, a double rod, and a rotary actuator. The left side has 2 hand valves and 1 solenoid-operated valve. The proportional valve is located above these 3 valves. The behavior of the proportional valve can be adjusted inside the electrical box at the joystick. Get in the habit of shifting these valves a few times once the pump is off and the lab is complete. This will drain any excess pressure still left in the system. The tank porting block is located at the bottom left. This block drains to tank. Troubleshooting, pressure getting stuck. These couplings are zero leak, and because of this, pressure can get stuck. If a student removes a hose and leaves pressure stuck in the system, you can drain the pressure using the pressure drain hoses. First, screw one in onto the tank porting block, then the other onto the fitting that is holding the pressure. If pressure is stuck in a valve, try connecting the valve to the tank porting block and shifting the valve. If pressure is stuck in a hose, try connecting it to the tank. If it won't connect to the tank, refrigerate the hose, then try again once it has been cooled. To avoid pressure getting stuck, always do 2 things before removing any hoses. Shift the valves that are connected to the system a few times and open the pressure release needle valve. Most issues can be avoided by doing this constantly. Proportional valve, solenoid valve, two-way valve not working. Make sure the 24-volt power switch is on and the electric box has power. Electric box not turning on. Make sure the fuse is working. To test, you should replace the fuse with a 20 amp fuse. Remember to wear gloves and safety glasses when working with any equipment. Do not touch any leaking fitting or hose. If you have any questions, please call us at 770-831-7677. Thanks for watching.